So thank you everyone for allowing us to participate in this wonderful conference. My name is Arif Rafiq, and today we're going to be talking about SUMO and the Transportation GeoXchange. So there's a number of things that I'd like to do during this presentation. One, I'm going to describe what this Transportation GeoXchange is. I'd like to introduce how this project that we are actively working on ended up resulting in this initiative to build this Transportation GeoXchange. But more importantly, I'd like to identify why SUMO, we've decided to bring SUMO and embed it into the Transportation GeoXchange, and what kind of value does SUMO actually bring to this initiative? That's the things that I want to be discussing today. And my name is Arif Rafiq, and I'm joined by a team who is behind me with this entire initiative. And of course, Jeff Kirchner is also on this team. We also have Giuliano Kirsting, David Stajan, Andrea Zagar, and we all are coming from Canada, and we're representing an organization called Esri Canada. So why don't I jump right into this, and let me describe the initial project that resulted in the Transportation GeoXchange. So when we got started in this initiative, we started working with an organization. It's a European organization known as ITEA. And the project name is called ITEA Smart Mobility Project. That's what we called it. And the SMART is actually an acronym for Spatial Modeling Analytics and Real-Time Tracking. And if you're interested in finding out more about the project, please do use that URL. I believe, Michael, that these slides will be shared with the audience. So you'll have a copy of this. You'll be able to click on that URL later, should you want to get some more information about the project. The goal of this project is to leverage spatial technologies and new data to enable and deliver innovative solutions in the transportation sector. Now, I know that this title is very lofty and the goal is quite lofty. And as we proceed through this presentation, I'll try to drill down and make it much more tangible for you. And at the bottom, we have a list of organizations that are participating in this project. Esri Canada, our organization, is leading this initiative, and we have a number of other entities that are participating spread throughout Canada and the Netherlands. And we're working together to get to this goal. Now, when we first started working on this project, we got together and we started thinking about what kind of challenges are there in the market that we wanted to address. So the first bullet says access to timely and authoritative transportation information. We've discovered, and I'm sure everyone in this audience knows, is that there is plenty of transportation data available for us should we want to go look for it, but very little of it is authoritative, meaning that the source of that information, it may not be coming from an authoritative government source that is actually the owner or the steward of that transportation infrastructure. Very little of that exists, but when you do find it, we find that it's often not timely. You know, some of it could be a year old, or at best, it might be even older than that. So we've discovered that this type of timely and authoritative data is quite difficult to come by. The other thing that we find is that of the data that's available out there, very little of it is available for advanced purposes, such as analysis and decision support. The reason we're thinking about this is consider where we're from. We are Esri Canada, and so our market that we serve is not necessarily the consumer market. We are serving primarily governments. And when you're working with governments, these are the organizations that own the transportation infrastructure, and their purpose in these types of systems of record is to perform things like analysis and decision support. So we found that there's a limited amount of information available outside the government space for wide usage. And so the final bullet here is, yes, we are Esri, but one of the things that we do not want to do is make this initiative an Esri-only playground. We want to be able to ensure that everyone can participate. And so one of our biggest focuses is to ensure that we enable open standards and cross-platform integration, so anybody can participate. In fact, we want more participation in this project as we go forward. So let me describe what these three market challenges ended up transforming into. We eventually started to build this thing called the Transportation GeoXchange platform. I love this image because this is the original back of the napkin drawing of the Transportation GeoXchange. In fact, Jeff Kirchner is the one behind this who drew that. He's the artist of this image. And there's a lot going on here. And I don't have the time to get into all of the detail here, But one of the things that we knew is that, or a few things that we knew is that this platform needed to be cloud-based. It needed to be geospatially driven. There's going to be quite a few real-time data streams coming into this. And essentially the purpose of this is to be able to collect information from static infrastructure, from real-time data streams coming in from all different sources, all different transportation modes, and ensure that that data is now temporal. What we wanted to do with that data is make it available for additional entities, not just us, but additional entities to create value out of that data and pass it on for other uses. So for example, if we were able to collect, whether or not a train or grade crossing is going to be fouled, then another value element of that could be to transform that and send it off to emergency responders so that they know whether or not they can expect a train to be fouling a crossing so that they can choose an alternative route, for example. Or even using cargo information to suggest to governments where and when to build more cycling infrastructure. There's quite a lot of value that can come out of it, but one of the things, we did want to embed some value to begin with. And so that's where some of this analytics, management dashboards, and planning and simulation on the right side of that image showed up. By the way, this is the revised version of that image. We didn't want to keep the hand drawing forever. So we had a few outputs that we wanted to make early on. And the one that I want to focus on today, of course, why we're presenting at this conference, is the one at the bottom right, the one called simulation. We know that because of our market, because of Esri's market being government entities, they're the ones who have ownership and the stewards of the system of record for our transportation systems. And they're the ones who are making changes to that. So how impactful could it be if when they're making changes to that system of record, they can perform simulations in their native environment and understand the impacts of those changes right away? We believe there's a tremendous amount of value there. And so that's why we wanted to embed SUMO into this platform so that they can all get that kind of capability out of it. So let me describe what we actually did. This is the process that we're using as part of this initiative. If you focus on the top right, we can see that there's an icon there for SUMO. What this does is it provides a simulated data feeds to this technology called ArcGIS notebooks. The reason we do that is because we want to be able to containerize those simulated data feeds so that they end up becoming native objects for the users of the system. So once those simulated data feeds become containerized, we can then pipe that through another technology, an Esri technology called ArcGIS Velocity. And the purpose of that technology is to ingest real-time data streams so we can see things happening in real time. Once all that's done, these objects then show up in ArcGIS Online. And if you're familiar with ArcGIS, you know that this is an environment or a platform where you can have multiple pieces of data streams, multiple pieces of context, all existing within the same geospatial context. And that's important. So we wanted to be able to do that. And so that the end result is that we can start using the TGX in real life. And so those two screenshots at the bottom here, the one on the right shows simulated SUMO simulations. You can kind of see the vehicles there, but it's within the context of real tree species and real 3D buildings. The one on the left is actually in Rotterdam, and a similar thing. So, but this one's done in a web application. So it's not done using the desktop app. It's actually available through the web. So all of this is pretty powerful. We've also been able to send data back to SUMO, which is, again, incredibly exciting for us as well. And so I don't want to spend too much time on that, but I will show you a quick screenshot. Actually, that screenshot's not available. So I'll tell you what I wanted to do, because we only have a few minutes left, is jump into some of the videos that our team has created. And I'm not going to go through the whole thing. I'm just going to go through two of these videos. The first one shows off the use of 3D ArcGIS web scenes using open data for the city of Montreal. Now, in order to do this, I just have to quickly be able to share my sound and share my video clip, and I will share this video with you now.
The main goal for this video is to present early results of the Transportation GeoXchange on the integration of real-time transportation data streams for photorealistic visualization of 3D digital twins. The texturized building layer for the city of Montreal is available from this ArcGIS Living Atlas of the World. The public trees layer uses data from the city open data as well. Note that the realistic 3D symbology matches tree species attributes. The traffic stream layer uses realistic 3D symbols of each transportation mode, where attribute-driven symbols change according to vehicle type, speed, or direction. For this layer, simulated data is generated by SUMO, Simulation of Urban Mobility, a rule-based system used to create traffic routes for multiple transportation modes like pedestrians, cyclists, cars, etc. This data is then fed into the ArcGIS system for real-time analytics and visualization. The interaction with digital twins on rich 3D environments helps enhancing urban awareness and allow for integrated geospatial analysis and intelligence-driven decision-making.
Fly a little closer into Toronto City Hall and we'll look down at the activities along Queen Street. In this example, we have two active layers. The red dots are the location of buses from a live feed provided by the TTC, the Toronto Transit Commission. The TTC refreshes their feed at a 30-second interval, so you will not see rapid movement in this layer. However, the blue, green, and purple dots are provided by a SUMO simulation. In this simulation, we are tracking the movement of people, vehicles, and cyclists. This simulation demonstrates how a well-tuned live feed could respond in a dynamic map.
I hope you enjoyed that very quick presentation. There we go. Let me just change my settings so I can come back and share with you. Perfect. So I didn't show the entire video. When you get a copy of this slide deck, you will have this link that you see in front of you so you can watch the entire video. There's a few other things that are quite useful in there as well, but because of time, I'm going to continue. And you might have seen in that video that it was quite exciting for us, but as a summary, what we needed to do, what we wanted to do is we wanted to containerize the SUMO deployment so that we can utilize the ArcGIS notebook server capabilities such as Python notebooks, REST services, SUMO libraries. The SUMO configuration, one of the key elements here is that it's being done on the server. This is server-side SUMO, and they're deployed as ArcGIS portal items. And that means that the users of the ArcGIS system can then use these SUMO deployments as native objects so that they can run concurrent simulations. And it's quite powerful from our perspective. You saw that we were streaming that simulation via WebSockets using ArcGIS Velocity. Another key element here is that we're able to take simulated data and live data along with other authoritative information like tree species, base map, feature layers, anything else that the user has at their environment, and host that within ArcGIS Online so that they can actually utilize that within their analysis or visualization. And of course, I don't have to get into the details about the benefits of cloud deployment. Everyone on this call probably understands the benefits there. Last slide of our presentation. Today, the things that you saw here as another summary was how we hybridize simulated data with real world data. We've been able to embed that within a 3D digital twin, as you saw. A couple of things that you didn't see in the video, but if you watch the remainder of the video, you're going to be able to see the camera position, view shed simulations. We have some of that. And of course, we have a dashboard presentation in that video as well, using simulated data from SUMO. Where we want to take this, we're still in the very early stages of the development of the Transportation GeoXchange. We want to be able to embed things like active lane changes, employ lane restrictions, impedance, some of the bylaws that are coming in from the government sources. We want those kind of bylaws to be able to impact changes to the simulation. We want to be able to show the impact of temporary work zones. Curbside management is a huge deal and it's only becoming bigger. And most municipalities are struggling with this type of work. So to be able to show or demonstrate simulations for that, I think will be very powerful. But if you notice, all of these future outlooks are aligned with where we feel, Esri feels that we need to be serving our community, and that's the government community. So these are the people who own the data. These are the people who are stewards about this data, and they're the ones who are making changes and impacting these laws. And if they had the ability to see the impact of those changes right away in a native environment for them, we think that will be incredibly powerful. So we're very excited about this. And I think if we continued, we can probably fill another 10 slides of things that we want to take this, this project to. One of the reasons we're sharing it here for everyone else is that, like we said, this is not just an Esri project. We want to be able to stimulate movement in this and utilize this Transportation GeoXchange so that everybody can participate and generate value for their uses or for their customers as well. So with that, I'd just like to give a big thank you to the SUMO community, and myself and my colleagues, we are here for questions. Michael.